At these temperatures, atoms get stripped down to bare nuclei, and the intense magnetic fields rearrange matter at the subatomic level. The result is a cosmic foundry that manufactures materials with properties that seem to violate known physics. Gravitational compression in black hole accretion disks creates pressures that dwarf anything possible in stellar cores. These pressures squeeze atomic nuclei together so hard they undergo fusion reactions that normally require the interior of massive stars. But unlike stellar fusion, which stops at iron, the extreme conditions near black holes push fusion processes far beyond the periodic table. Elements with atomic numbers in the hundreds get created routinely, including superheavy elements that decay instantly under normal conditions but remain stable in the black hole's gravitational grip. Scientists have identified specific materials that form only in black hole accretion disks, and these substances represent the ultimate treasure trove of valuable elements. Quark matter forms when protons and neutrons get crushed so hard their internal structure breaks down, creating a soup of fundamental particles held together by the strong nuclear force. This quark matter exhibits properties that could revolutionize technology: perfect electrical conductivity, room temperature superconductivity, and the ability to store enormous amounts of energy in tiny volumes. The latest observations from the James Webb Space Telescope have detected spectroscopic signatures of elements that shouldn't exist according to current theories. Black hole accretion disks show evidence of containing stable isotopes of superheavy elements like unberyllium and unbihexium, which laboratory experiments suggest should decay in milliseconds. The gravitational fields around black holes apparently stabilize these exotic nuclei, creating materials with applications in quantum computing, energy storage, and space propulsion that make current technology look primitive. Black hole jets represent another source of incredibly valuable materials because they contain matter that has been processed through the most extreme conditions in the universe. When black holes feed on surrounding matter, they don't consume everything. About 10% gets ejected in powerful jets that shoot out at nearly the speed of light. These jets carry materials that have been compressed, heated, and magnetically processed in ways that create substances with unique properties. Observations of the supermassive black hole at the center of galaxy M87 have revealed that its jets contain concentrations of rare earth elements thousands of times higher than anything found in our solar system. The jet material shows signatures of neodymium, europium, and terbium in such high concentrations that a single cubic meter would contain more rare earth elements than Earth's entire known reserves. These elements are essential for manufacturing electronics, renewable energy systems, and advanced materials that modern civilization depends on. The magnetic fields around black holes reach strengths of trillions of Gauss, powerful enough to compress matter into crystalline structures that remain stable despite containing elements that would normally repel each other. Magnetized accretion disks create materials where atoms arrange themselves in impossible geometries, forming substances with mechanical properties that surpass any known material. These magnetically forged compounds could enable construction materials stronger than diamond, superconductors that work at any temperature, and energy storage systems with densities approaching those of antimatter. These cosmic factories operate on scales that make human manufacturing look microscopic. A single supermassive black hole processes more matter in one day than human civilization has used throughout history. The Milky Way's central black hole, Sagittarius A*, consumes about 1 Earth mass of material every 1,000 years, converting it into exotic matter states worth more than all the wealth on our planet. The processing never stops because black holes continue feeding for billions of years, accumulating reserves of valuable materials that dwarf every other source in the universe. The energy crisis facing human civilization could find its ultimate solution in black hole physics because these cosmic monsters demonstrate perfect efficiency in matter energy conversion. Unlike nuclear reactors that convert less than 1% of matter into energy, black holes can extract up to 42% of an object's mass energy through the process of frame dragging and magnetic field interactions. This efficiency rate exceeds even antimatter annihilation and represents the theoretical maximum for energy extraction from matter. Black holes create forms of matter that could solve Earth's energy crisis by providing materials that store and release energy with perfect efficiency, making every other power source obsolete.